Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about solar water heaters. So let's dive right into it. Now, primary reason we go into solar system is simply because of cost. Well, reality is we need a lot of hot water, and God help you if you are in a hotel industry or hospital industry or large family home, we need a lot of hot water, and water is water. It takes a lot of energy to heat up. Consequence, money. So it reaches a point where we are like, hey, isn't sun giving us free energy? Why can't we use that energy? So it becomes a normal thing. Now be mindful, solar systems are not so cheap that you can just like lol. It is something that you have to be mindful, not only because it costs a lot of money, it also requires a certain amount of dedicated space. So you have to be a bit mindful of that. However, the moment you are talking about large residential complexes or anything that, like, let's say for example, if you have 5 people plus, it starts to make sense. If you're talking about hotels that are consuming hot water even in summer, for example, when they try to, like, wash white clothes, white bed sheets, they do need a seriously large amount of hot water. Hospitals, they need seriously large amount of hot water. So in those sort of time, it makes sense to go into solar system, because again, water is water. Even heat pumps, while they do work amazing, in winters they do not work as amazingly. While in summer they are a good thing, but in, again, if you cannot, if you do not need to spend energy, wouldn't that be amazing? Hot water for free. So that's the end goal. So logic behind is very simple. Sun gives us a lot of heat for few hours. That's the consequence. It's not 24 into 7. It's not when we want to turn it on. It's just few hours a day we get a lot of energy. So what we have to do is figure out a way to isolate things, basically water, from ambient temperature. That's the first requirement. And then we need large surface area to compensate. For example, how we used to compensate for low thermal, basically low energy heating elements in storage water tank by using temporal stretching. Basically, we are stretching 500 watts of heating element to, like, hey, take 4 hours to heat up the water. It's more than good enough for that. And if you are talking about continuous system or tankless system, at that point in time, is like, bro, 8 kilowatt for one tap. So that's what we have to understand. You can stretch or compress things relative to each other. So we are in a scenario where it's winter. So fundamentally, that means sun is not dumping enough energy. So what can you stretch? You can stretch the surface area. The larger the surface area, the more energy you can extract. And if you're thinking about, hey, what if I get a PV, solar PV array? Well, PV systems are kind of in an odd spot, because if you are talking about resistive heating, meaning I have electrical energy, I run resistors out of it, it does not make sense. Nobody has done calculations for what will happen if you have solar panel, let's say large rooftop solar system, off grid system, and then you are running heat pump. I have not seen the mathematics there. And it might be, especially in low ambient, I don't think so, but in high ambient, basically, let's say it's only 10 degrees Celsius rather than minus 10 degrees Celsius. I think at 10 degrees Celsius, you may get hot water better from PV system, but cost would be exponentially high. So compare that to resistive system, there's no go. Like if you're comparing electric resistive heaters, this system flat out makes more sense, flat out, because again, sunlight comes in, voila, heat. There is no conversion. Basically, photon, what does photon do when it hits something? It vibrates it. What is vibration on average? Heat. So direct energy conversion. We are not getting any hululu, any conversion. It's like, oh, it's striking a atom, then it's creating electron, then electron is pushed into one direction and then it goes through a system. Then it's like, no, it's just photon, heat, done, go home. It's far more efficient. Now, it does require electrical backup. Be mindful. In early days, people had really bad experience with these things, and simply because nobody figured out that there could be time where these things are spent. For example, let's say you have a system that is perfectly scaled for your household. Your household have 4 people. This is more than good enough. But what if 2 guests come in? They take bath in your house. Voila, you no longer have hot water. Or some days, like let's say it has been raining continuously for a very long time. Voila, you no longer have hot water. In those sorts of people have really bad reviews about this. It's like, oh, it's not reliable on that. Again, sun is not that reliable. So all of the systems that are seriously made by any serious company, they will either give you an option, and if it's a really high reputation company, they will not even give you an option. It's like, dude, we are giving you electrical backup. Use it. Again, it should not be needed. Most of the time, it won't be needed, even in cold winters. But sometimes, just in that edge case, where it's like, bro, I got you. Because what the hell you gonna do at the end of the day? It's like, let's say it's middle of the winter night and you ran out of the hot water. You use the electrical system. Now, the insulation and the tank size, they are designed in such a way that should last more than 24 hours. Some, especially large ones, are good enough, they can last 48 hours. So generally, one day of use, and whole night it still should have hot water. And that's why you will never find them on small capacity. They start at 100 liters. It just makes sense from a mathematical point of view, from volume to surface area point of view, to have as large as possible. So if you have like 2000 liter systems, they will last hot water for a very long time, especially if drain time is too low. So that's the logic behind it. So there are two ways of achieving it. First is flat plate, and these are very well insulated box with solar input, meaning they have a glass that allows sunlight in. Now, depending on the manufacturer, depending on the cost, there could be few ways of dealing with the glass. For example, you could have toughened glass and with a coating on the inside, because you have to understand physics here. If you heat this puppy up, meaning sunlight starts to heat this up, it starts to radiate heat away. If it's not isolated from all sides, it's gonna dump the heat into the ambient. Now, let's say you put a lot of insulation on all 4 sides, all 5 sides. So you have on the bottom side, all the sides, awesome. What about the top? Top is a thin place of glass. Now it heats up, it dumps all the heat into ambient, and voila, the temperature of this puppy never goes beyond a certain point, because that is becoming your bottleneck. So sometimes we will use coating to solve that. Sometimes double pane glass is used to make sure that it's completely isolated from ambient. In those sort of time, you do get a bit higher ambient, but consequences, your price of the equipment does go up. So you have to understand, and the interior is made completely black and water does run through it. So it does have the benefit that there is nothing fragile in here, so it does handle high water pressure, meaning if you have a high pressure water pump, it can handle that. If you have a scenario where, let's say, pressure on the tanks that is feeding in into this is very high, it can still handle that. If you have like very large setup of it, it can still handle that. They are really good for pressure, but max temperature is lower compared to the vacuum systems, which we'll talk on further. And they are a bit more robust for rough environment. For example, if you have a scenario where you have hailstorms, this have much higher chances of surviving compared to vacuum systems. And if you have monkeys, like in India, we do have boatload of monkeys. Some states, not every single state, some states we do have monkeys. In those sort of time, people do prefer this simply, even though the maximum temperature you can achieve is a bit lower, it still is like more than good enough, and making sure it's not getting damaged, because again, monkey damage is not covered under warranty. So that's far more desirable for many places. Rougher environment, this is like, I got your back. Then we come to the second option. This is most likely what you think about when we say, solar heater, is evacuated tube. Now it's using vacuum envelope for insulation reason. So you have a glass tube, it has another tube on top of that tube, and there is vacuum in between them. So cold ambient air cannot touch basically the hot part, and that hot part gets energy using photons. Photons can easily penetrate the glass without any issue, not to mention including infrared also, and it heats up, and the photons that it radiates away bounces back. So it has perfect greenhouse effect while perfectly insulating it from the ambient, and voila, this gets hot. And it can achieve high temperatures, as in like 80 degrees Celsius is achievable on large water volumes. So it's really good in terms of quality of hot water. Now, there are two ways of using the heat that are generated by these. One is this tube itself is directly coupled to your tanks, and water goes into the tube. That's awesome, because that has the maximum amount of surface area, because water will conduct perfectly. But there is a problem. If you have that, like most of the tanks that are, let's say, in the range of 200 liters to 500 liters, generally they have this pipe directly going into the insulation tank. It does work, but this glass tube is fragile. So fundamentally, it limits the pressure, maximum system pressure you can have. So in scenarios where you have basically cold ambient, you cannot use flat plates, you have to use this, and you need to connect multiple of them. What you do is heat pipe variant. These are far more expensive compared to this system, because this is just a tube, and even if one or two or tube breaks, you do have to replace them quickly. Not as in like it will damage the machine. It will just like, you'll think, oh, I'll replace it when I get time. No. You will stop getting hot water, because this literally acts as a giant heat sink instead of heat pipe. So it dumps all the heat from the insulator tank. So even if you have, let's say, majority of them working, one broken one can dump enough heat into the ambient, where it's like, instead of getting 80 degrees Celsius hot water, you will be getting like 50 degrees Celsius. So it's vital you keep checking them, and if there is a breakage, you can replace it. It's quite easy to do so, and it's quite common nowadays, so you can buy them, and many large installation, they do have few of them in stock. So it does transfer heat from photons to into water, and water directly couples it. In heat pipe, it does do the same thing, but problem is how the heck you couple heat of large tube into a tiny heat pipe tube. There lies the problem. That's why these things are a bit more efficient if you are comparing like how many square meters you have and how much oomph you get out of it. These are efficient. These are less, little bit less. Do not expect like, oh, this is like 50 kilowatts and if you use this you'll get 60. It won't be like that. It's like little bit. So many times people do what they do, they pull this puppy out and they put sand in it. So you have to understand the biggest problem there is the glass is getting heat from all sides. Awesome. But how the heck you conduct the heat from glass walls to the heat pipe? So there is aluminum foil there generally. Again, you have to figure out transportation also. So companies cannot afford to put sand in there. They have to put something that is very thermally conductive and cheap enough. Aluminum is the only thing that fits the bill. So there are certain limitations. Be mindful. This puppy will give you the maximum efficiency. This will give you the maximum pressure ability, meaning you can have all of this, and this bulb can go through a system where you can have very high PSIs, very high pressure, and then you can chain this puppy up. At that point in time, this does not make sense. This starts to make sense. That's why these two designs agree. For large pressure systems, you will have heat pumps. For basically small system, generally less than 500 liters, you will have direct water flowing through it. But it does need cleaning, because again, it's not something that you can clean by a simple wiper. It does require a bit of cleaning, and they are fragile. So if you are in a scenario where you have hailstorms, these are generally things that people do not like. Or sometimes you could have monkeys, they generally do break them. So it is something that you have to be mindful about. So these are the evacuator tube. Does give you higher pressure, temperature though. So you have to understand this. This also have details. There is a reason we have a saying, devil is in the detail. So detail is, this puppy also need maintenance exactly like all other water system. Tanks and tubes needs descaling properly, specifically the tube system where you have tube that directly has water going through. You can see that like how much scale builds up on the water itself. Basically in electrical system, when scale builds up on the heating element, heating elements can keep running for longer to heat up the water. It will defeat that insulation. Again, over time, insulation will always win. That's why first your power will go up, then your heating element will short out, and then you'll pull it out and it's like completely white and destroyed because insulator finally won. Here, you do not have continuous power. So you reach a point where it's like you boil the system, you put the water in, everything is awesome, everything is handy dandy. For 1 or 2 years, you are happy as a puppy. And in 3 to 4 years, you're like, dude, why are we not getting that same love feeling, The water is no longer like, let's say, instead of 80 degrees Celsius, you're getting 75. 1 year after that, it's like, I'm barely getting 60 degrees Celsius water because it's not cleaned. And you're like, hey, I cleaned it from outside. No, these had to be descaled, especially if you have a like very high TDS in your water. All those things have to be together, because be mindful. That's why I said that water ring into the tube does improve efficiency, but does make cleaning a hassle. But it has to be clean, and these systems are designed in such a way, and nowadays these are common enough that everybody will tell you how to do it yourself, or you can hire a professional to do it for you. These are common things nowadays, and again, do it periodically and you will have a good experience with your system. Don't do it correctly and you'll always be that person on Amazon reviews like, this does not work for me. Again, simple things, whenever the simple things break, generally is the user's fault. So descaling properly and periodically, as in like every 4 years, is compulsory. They also have anode rod. You have to replace them, check them regularly. Collector also needs cleaning periodically, because this is the weird part about this. This does not go from I'm working to not working. It's not like a car where it's like, oh, something broke, car is shut down. No. It's like it slowly leaches itself. So it will go from awesome amount of experience to like, oh, not bad, to like, it would be nice if it was better. But again, it's not bad. So it will brick by brick go down, and then by the time it's like, okay, this is not working. And if you try to descale them, you may have a scenario where scaling is too serious. Again, it could damage the tubes from inside also. Again, very unlikely, and you have to really not care about hot water for it, because again, if it's that bad, that means scaling has been happening for few decade, 1 decade at least, unless you have ludicrously bad water. In those scenarios, nothing will last. So these are the details that you have to be aware of. Only then you can have a truly good experience. And always buy electrical backup systems in all the solar system. Do not be like solar only and one bad day experience, you're like, oh, solar is useless. It's like there is a point where sunlight may not cooperate with you. So you have to work around it. And again, does not mean your electric bill will be the same as your electricity. It would be like fraction of what it would have been otherwise. Because again, even if you are heating, let's say you set the heating element continuously and it's like, hey, heat the water to, let's say, 50 degrees Celsius. Electrical heaters are directly proportional. The power draw is proportional to the starting temperature. If they are heating hot water from, let's say, a solar water heater, and let's say sun was not cooperating, you only had 30 degrees Celsius water, it only has to do 10 degrees Celsius delta. Super easy. Now compare that to normal system, you may have a like 10 degrees Celsius water incoming. Yeah, your power draw will be exponentially high, even though the final temperature is the same. That's why do not be stupid. Do buy an electrical backup system on it. Always. Like, shut up and buy it. So this was my presentation on basically solar water heater. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you are free. And as always, thanks for watching.